Alright, this is Shen, and today is the first lab for the fan part. And we have uploaded a CAD model for you to create the fan part. So you can go to web course, and it's on the under the folders. And after you download your zip file, you should first extract them into one folder, and you should extract all the files. Okay, not only you need the assembly part, but you also need all the other parts. Okay. All right. So first, we're gonna open the assembly part. All right, that's the CAD model we modified, optimized for the simulation. So we removed the grips, and we removed the trigger, which is not used in this simulation, and we deleted some tiny features like the teeth, okay, and the chamfer here. It's also deleted, and we idealized the screw. Okay, now um, as usual, we first click Start and advance the simulation. Okay, this will bring us into this window, and we're gonna right click on the .prt. It's gonna be new fan and simulation, and nothing special. Click OK. Alright, here we're gonna still keep clicking OK, and I think we haven't done dynamic yet, so just keep everything by default and click OK. And now we are in the sim. Okay, let's go to the fan first. Okay, we then will create some mesh in the fan. So these two jaws gonna be the 3D mesh. By the way, we also separated this the jaw handle into two pieces, the jaw and the handle. Okay, since we're gonna create a 2D mesh on the handle, the connector, and also this piece of the handle. Okay, so first, to create those 2D mesh on this kind of parts, okay, that's sheet metal. We want to find the middle surface of this piece. So what do we do? How do we find the middle surface? We're going to modify this this file. It's called the idealized part. So idealized part is actually let's say idealized from your CAD model, from your this PRT file. Okay. So let's go into this idealized part, and basically this is saying you should promote, or you should um, separate your geometry from the whole piece so you can modify that CAD. Okay, so here in the idealized part, the whole geometry is actually considered as one piece. So if you want to modify either of this piece, you cannot do it now. Alright, so we want to first separate a single part from the whole piece. That we need the promote command. Okay, so it promotes a body from a loaded assembly. So we should click this promote body command. Then you can promote them one by one, or you can just pick what kind of which part you want to promote. So we want to promote these three parts, and you can click OK. Alright, now they're promoted, and which means they're separated from the whole assembly. Now let's try to find the mid surface for these three parts. So the command is here. Okay, you want to expand this menu. Go to mid surface by face pair. So here you NX wants us to select the solid body, and if you hover on the jaws, you can see nothing happens because they are not promoted. Okay, and when we move to the solid body, it can be picked up. So first we will start from this jaw handle, and the strategy you want to make sure it's progressive. Okay, I think by default it's progressive. So I did something here, and you don't have to worry. It's gonna be progressive by default. Then go down here. That's the automatically create face pair. Okay. So after first you pick the solid body. Second, you want to check it's progressive. Third, you want to click this button. Okay. Once you click, you see there's a mid surface has been created. Okay. Then you can just click OK. Now let's check the mid surface. So I'm gonna right click on the top surface and hide this. Now the thing left is the mid surface of our handle. There's a little bit separation here because the handle, the geometry of the handle. Okay, now we can keep going on for the two parts left. Alright, so let's first select the connector, and again progressive, and the third step is to create the mid surface. So we click here and look, there's mid surface. I can click OK. Alright, again we can check by hiding the old geometry, and that's our mid surface. Alright, so third part, progressive, and then create face pairs. Alright, and click OK. Let's hide this. Also, you can see there are actually two pieces of mid surface has been created. It's the same as this one. And now let's go back to the fan. Okay, so this window is telling you that your idealized part has been modified and it has been upgraded in your fan. So we are in the fan, and you can expand this polygon. And usually we only have polygon body. Now here you can look at they have different icons. That's your mid surface. Okay, so if we turn everything off and you turn on those mid surface, that's our mid surface. Alright, another thing is it's a good habit that you rename all these polygon, because you're gonna do mesh on these polygons, and if you want to find a specific polygon, it's gonna be a pain to find the one out of 11 here, probably 100 in another bigger part. So we can right click here, rename. Okay, that's our screw, and I'll keep doing and trim this video. Alright, so I have renamed all these polygons. So let's start with the mesh. Okay, let's turn off everything first. Now we're gonna start mesh on this parts by part. Okay, first for this handle, we call this handle B. Okay, the surface is it's a mess on the surface. You have a lot of tiny surfaces. Okay, so we can do something on this surface. That's gonna be the command called the merge face. Okay, we're gonna merge those small faces into a big continuous face. So we're gonna use merge face, and you want to choose the second icon and keep everything by default 15 degrees, and make sure you only have this polygon turned on. Okay, and I'm gonna pick every surface here and click OK. You can see right away now it's a big surface. Okay, and a big smooth surface. Alright, now we're gonna create 2D mesh for this handle B. All the 2D mesh for this part is gonna be quad 4, and the size for the element is gonna be 0.1 for all this, for this whole project. Okay, and okay, pick this object, and don't worry about those the other stuff. 0.1 quad 4. Okay, let's click apply. Now you will have some warning here. Right, violates some kind of a criterion, and that is for those quad element. It's better to have them the four corners, the degree, the angle of this four corners close to 90 degrees. And look at this piece. You have a huge angle here. That is not very good for the simulation, but it's fine for our part. So we just ignore those warning and keep going. Okay. Now we can turn off handle B, and we are going to mesh handle A. So handle A is also 2D mesh. Okay, also quad 4 and 0.1 size, and then click this object, which is pretty easy, and that's the whole warning again. So don't worry about that. Just keep doing. Hide that. I'm gonna show the connector. Then 2D mesh. Okay, the same parameter for this piece. And now we have 3 pieces of the 2D mesh, and next step we're gonna go ahead and do the 3D mesh. So that's gonna be for our 2 jaws. Okay, we are going to use 3D TETRA mesh, and here we're going to use TETRA 4, which is linear TETRA. And here I have to emphasize on this: linear TETRA is a big no-no for solid piece. It's very stiff. It's not good. It's not very good for simulation. As if you recall from your homework, those multi-beams, the linear TETRA is terrible in terms of simulation. But for our part, okay, the jaws are very strong. Those are strong pieces compared to those sheet metal, the handles. So we can use them in this simulation. But just remember this: linear TETRA and the linear triangles are really bad in terms of the simulation. Okay, so we just keep doing this, and it's gonna be linear TETRA 0.1 inch element size, and click apply. You have one 3D mesh. We can select the second jaw, and yeah, I want another collector for this jaw, so click apply. Alright, now you have two 3D solid for the two jaws and 3 pieces of 2D mesh for those 3 parts. Okay, let's turn on the polygon back on. So turn off this 3D for those sheets. If you look at here, we still have a little bit piece that's not meshed. So for this piece, we are going to ignore the polygon. Okay, and also we can turn off all the polygon. For this piece, we're gonna use extrude mesh from the edge of this big piece and the bigger 2D mesh. So this piece of mesh is gonna based on this the edge of this big piece instead of the polygon. Okay, and let's start. Okay, and go to insert element, then choose extrude. Okay, here in extrude we can select the element edge. Let's try to first hide this polygon so we have a clear view. You want to pick the edge of this the bottom edge of this big piece. Okay, and note how the edge is highlighted. Click this. That's only one edge. Okay, now we need some clever filter. We can come here and choose feature element edge. Okay, that's your filter or the method. Okay, so again we're gonna pick one edge from here and then see what happens. Okay, if you can see the whole edge has been picked up. Okay, that's the good thing about this this filter. Alright, so now we want the number of copies. That's gonna be 10 copies. So which means we're gonna generate 10 element when you extrude, and each element, okay, is 0.05 in size. So the whole mesh is 0.05 05 times 10. It's gonna be 0.5 inch long, and it's gonna be a cylinder extruded from this edge. The element type is again CQUAD 4, and we still need to specify a vector for your extrusion. So now we need the polygon body. Okay, we want the extrusion to be at the direction of this polygon, this cylinder. So when you move your cursor here, then you can pick the polygon face. That is your center line of the cylinder. Okay, and we want this direction to be reversed. It should be coming out. So I have the preview here. By default, it's closed. It's like this. So you can click on the preview, and that's your extruded mesh. Okay, on the direction of your cylinder. Each element here is 0.05 inch in increment, and you have 10 elements. Okay, let's click OK. So that's the element we just extruded. Alright, so what's next? Next thing is we want to check for the duplicated nodes for free edge. So first let's have a look at the element edge. Okay, you can check them like part by part. You can also check them for the whole piece. So you can select the display. Okay, or you can select them all. And let's click Generate Element Outline. And it's good to look at the wireframe. Okay. So you see here, the 2D mesh and the extruded 2D mesh, they don't have a free edge between them. So that means there's no duplicate nodes. They're one piece. Okay. I don't know if Dr. Zada has emphasized on the free edge. So the free edge means you have elements on one side of your node, but there's no element on the other side. So by default, by definition, the edge, the outline of your element or of your mesh should have a blue line. That's your free edge, and the element inside your mesh should not have free edge. And sometimes if you have two pieces of mesh and they look like they're one piece, but if you have one blue line in the middle, the computer, the Nastran, will think this is two pieces of object. So if you, let's say, if you pull them, they're gonna separate. Okay. That's why you need to check the free edge. And since we don't have free edge here, so we don't have to do the duplicate nodes. Okay. But if you have duplicate nodes, like say if here the extrude piece and that 2D mesh has a free edge between them, you have to use duplicate nodes. Pick this two piece, and you will see a lot of blue dots between them. Then you have to merge those nodes, so you don't get duplicated nodes. Okay, but now we're good. So that's all we need, and this is the for the first lab of our fan part. Okay, so pretty much we have finished the mesh. Next lab we're gonna do the connections, or in other words, the assembly of our fan. So this is assembly in fan instead of assembly in CAD. Okay, we're gonna use like RBE2, RBE3 to connect those pieces into a working fan model. Okay, thank you very much.